Hello friends, this time I'm going to share my knowledge on 5G authentication procedures as per 3GPP specifications. So we have two different types of authentication procedures. One is EAP ACA and second is 5G ACA. ACA here stands for Authentication Key Agreements. So in this slide, I will be specifically focusing on 5G ACA. So without wasting time, let's move ahead on the next slide. So friends, I have used animations in this slide to make this presentation more meaningful and interactive. So let's see the first message. It is the N1 message. N1 message is can have either SUKI or 5GPT as identifier. SUKI will be used when you is doing first time attach request to the network. Then SUKI is used, subscriber concealed identity. And if it is not doing for the first time, then 5GPT is used. This message is sent over N1 interface to the SeEF. SeEF stands for Security Anchor Function. This is responsible for all the security procedures between UE and the network. So what SeEF will do? SeEF basically will check if 5GPT is valid, then it is having the SUPI of the user, subscription permanent identity. And if it is not valid, it will use the SUKI. It will also add SN name, serving network name. It is nothing but the name of the network or the network that is providing the services to the UE. This can be visiting network also. So service network is kind of PLMN. Now SEF will call AUSF services. So this message and AUSF, let me highlight it. And AUSF is the interface that SEF is going to use. UE authentication, I have mentioned it as UE auth, is the service of AUSF that SEF is going to use. And authenticate request is the request of that service. So this is the way in which we will read the messages of over SBI, service-based interface or service-based architecture. This is the way we'll understand the messages of SBA architecture. So all the messages will flow over SBA now. This is once again I'm going to explain. NAUSF is the interface or the server that we are going to use. UE second one is the service of that server that we are going to revoke or we are going to use. And third part is the request of that service. What kind of message we are sending? It's a request response, what kind of it is. So this message will flow towards AUSF. AUSF will see that I need to consult UDM. So it is going to make new message and UDM UE authentication get request, get the subscription data of this user. So this message is sent over SBA interface to UDM. What UDM will do, if SUKI is received in the message, then UDM will deconceal it to attain SUPI, subscription permanent identity. With that SUPI, it will check the subscriber's profile and see what authentication method is subscribed for that user. If it is 5G ACA or if it is EPACA. So we'll focus on 5G ACA. Let's say it selects 5G ACA or UE is subscribed for this procedure, for this method 5G ACA. So now UDM is going to make 5G HEAV. This stands for 5G Home Environment Authentication Vectors. And this will have RAND, AUTN, expected response, and KAUSF key. These four parameters will make 5G Home Environment Authentication Vectors. These will be made with CKIK keys that are already stored in UDM and UE SIM. Now with these authentication vectors, NUDM authentication UDM will send the response back to AUSF in this message. Now AUSF will have will do these functions. It will store the response res and KAUSF that it received from UDM. It will derive hash expected response and KSEAF key from expected response and KUSF that it received from UDM. So from UDM, it will derive two more parameters H XRES and KSEAF from XRES KUSF respectively. And with these two parameters, it will make 5G authentication vectors. So two parameters are changed and we can get 5G authentication vectors from 5G home environment authentication vectors. So I hope you can understand the difference between two: home environment authentication vectors and authentication vectors. The basic difference is these two. So now 5G authentication vectors are sent from AUSF to SeEF. Now SeEF will choose two parameters from authentication vectors, RAND and AUTM, and it will add the identifier KSI like we used to do in EPC with KSI ask me. Here it is NGKSI. It is nothing but the identifier of some another key, that is AMF. We'll see in the next slide. Don't worry. So this message is sent to UE over N1. Now what UE will do? UE will check and match AUTN that is received from the network and the one that is it will derive from the keys it is having, and check if it is matching. So this is the network authentication, means UE is authenticating the network if the network is authentic or not. Second thing UE will do, it will calculate RES, the response, and key KAUSF from CK and IK keys. So CK and IK, ciphering key and integrity key, these are the master keys that are stored in UDM also and in UE as well. So these two keys will have to generate all the related keys. So UE will calculate response and these two from CKIK. Now UE will send that response that it calculated back to SeEF. Now SeEF will, will derive the hashed response from, the response it received from the UE. And if that hashed response matches with the expected hashed response, then serving network authentication is done. So guys, I would like to tell you here one thing, that in 5G we have two stages of authentication. One, that is the serving network authentication, that is done by the serving network, and the second that we'll do in the next stage or in the next message is the home network authentication. So what will happen? It will send the message to AUSF, and what AUSF will do? The same response that you send to SeEF, now SeEF will send to AUSF. Now RES will be matched to the expected response, and if they match, then home network authentication is done. So this is how we do two-stage authentication in 5G. One is the visiting network or the access network or the serving network authentication, and the second is the home network authentication. So serving network will inform home network that I have successfully authenticated the user. Now it's your turn to authenticate it. So when this is done, home network has authenticated the UE. It will send the response back as the success to SeEF. So once home network confirms the successful authentication, KSEAF becomes the anchor key, and that key is used to derive all the other keys like KAMF, KNAS, K G0B, K and SIIWF, interworking function that we call it. So this is, friends, the last slide. In this slide, I have taken this from the 3GPP document, and here you can easily see that how keys are derived or interlinked from each other. This is the network side, and this is the UE side. So we have K key, then we have CKIK, and if ePAKA is used, CKIK is used to derive these two keys, then AUSF, and if it is 5G AKA, CKIK will directly derive KAUSF key, then KSEAF, that is the anchor key, then KAMF, the AMF key. This KAMF key is used to derive these three keys, four keys, sorry, and K G node B is used to derive further RRC integrity, encryption, user plane integrity, and encryption. The one more difference in 5G is as compared to EPC. In EPC, user plane integrity was not performed. Only user plane encryption was done. But in 5G, we have integrity also. So that is it, guys. Thanks for listening to my presentation. Thank you. Bye.